Okay, Assalamualaikum and good afternoon. Okay,
Waalaikumsalam.
one more student is missing. Okay, is Imran here? Muhammad? Okay. Okay, so we
Ada
have,
doktor.
okay, ada, nampak dah. Okay, we have enough students so I can start now. Okay.
Waalaikumsalam.
Nampak tak? Apa yang awak nampak? Tapi dia tak pergi kat situ je. Nampak slide ni Okay.
Nampak doktor.
Saya nampak dia nak buka PowerPoint ni elok sikit. Tidak dia lari-lari. Okay. Okay, we have finished up to SR lash. Remember this? Okay. So it is important for you to remember this truth table for SR lash. Okay. That is when 0, 0, no change. 0, 1, when S is 0. Okay, for reset is 1. So Q bar is 1. Q equals 0. So when S is 1, R is 0. So Q is 1. Q bar is 0. So when 1, 1, that is invalid condition. So now we look at the S bar, R bar latch. Okay, so this is an active low S latch. Wow. Okay, why is active low? Because you look at the input here, you have bubble here. Okay, so this is for an active low. The active low SR latch is in a stable or latch condition when both inputs are high. Okay, let's see how. So assume the latch is initially reset. Okay, reset meaning for Q is 0 and Q bar is 1, right? Okay, and the inputs are at the inactive level, that is 1. So to set latch, you want to set Q equal to 1. So a momentary low input or low in signal is applied to S bar here. Okay, while the R bar here, you see here, is remain high. So you see here, this is the momentary low. Okay, so when this is low, you see the bubble, so the output will be high. So Q is high. So this Q goes into the second OR gate here, but now you have bubble here, so 0, okay, here, and here is 1 because the bubble, so it both are become 0. So 0, 0, you get Q bar equal to 0. Okay, so to reset meaning you want Q bar to get 1, yeah? Okay, so to reset the latch, okay, a momentary low, see here low, is applied to R bar, okay, while S bar is high. Okay, so never apply an active set and reset at the same time. You cannot do that, Okay, so because it becomes invalid. Okay, so this is for S bar, R bar latch. There is a bubble at the input of OR gate. Okay, now look at here. The active and active low input S bar, R bar latch is formed with two cross couple NAND gates. Mana pergi hilang? Patutnya ada circuit dia. Sorry yang hilang, saya tak tahu pergi mana. Okay. it is here, but when I make it bigger, disappear. Okay, can you see that? Something is not right with my mouse here. Okay, so you can see this is the symbol for S bar and R bar here. So you see you have bubble at the input. Okay, so look at the truth table here. This first one here is for S bar and R bar. So when both are 1, there is no change. Okay, latch remains in present state when both 1. So when S equal to 0, R bar here equal to 1. So Q is 1. Okay, Q bar is 0. This is when the latch is set. When S bar is 1, R bar is 0. So Q is 0, Q bar is 1. This is when the latch is reset. When both are 0, you can see here, you get the output of both 1. So this is an invalid condition. Okay, so now look at the SR latch here. The active low S bar R bar latch is available as the 74LS279A IC. So this is the IC for S bar R bar latch. So it features 4 internal latches with having 2 S bar input. Okay, so you can see here at the input here. Okay. Okay, you have here 1 here. This is S1, S2, and then you have R here, and so on. Here S1, S2, O3. Okay, let's see here. Okay, it has 4 internal latches. Okay, 4 internal latches. So here 1, 2, 3, and 4. Okay, with having two having 2 as input. Okay, 2 having 2 as input. You can see here as input. Okay, to set any of the latches, the S bar line is pulse low. Okay, so it is available in several packages. S bar, R bar latches are frequently used for switch contact bounce circuit as shown below here. So normally it is used as a switch contact. Okay, so this is from position 1 to 2, and then you can see from 0 from position 2 to 1. See, 1 and 2 is referred to the switch here. Okay, so now look at here gated SR latch. Okay, previously you look at as SR latch only. Now this is gated SR latch. Sekejap Okay, now gated SR latch. The gated latch is a variation on the basic latch. Okay, the gated latch has an additional input called enable. Okay, you see here, this is enable, EN here. That must be high in order for the latch to respond to the SR input. Okay, so you must refer to the enable here. The enable must be high, then only the latch is respond. Now look at the example here. So show the Q. Q is here. Okay, Q output with relation to the input signal. So input signal is given here. Okay, you can see here the timing diagram for the S, and here is the timing diagram for the R. These are the input. Okay, and show the Q output with relation to the input signals. Assume Q starts low. So you assume Q start low, and here is the enable. So remember, the enable must be high. It's mentioned here, must be high in order for the latch to respond. So you can see here, this is high. This part is high. This part is also high. So how is the Q? The timing diagram for Q. You start with low. You see here low. Okay, this point, this is high. And then you look at the R. R is low. S is high. So when S is high, what is Q? Look at the truth table. If S is high, R is low, Q will be high. Hello? Where is everybody? Are you sleeping?
Ya, doktor.
Are you sleeping? Are you sleeping?
No.
Brother John, saya cakap seorang ke? Nampak saya tak?
Nampak doktor.
Anda dapat, doktor.
Dah nampak dah? Okey. Lupa nak tarik plaster ni. Okey. Okay, so now you look at here, enable here. Enable is high. So at this point, look at here, at this point here, which is from low to high here. This is the positive edge. We call it, this is positive edge. You see here? Okay, you can use your ruler. Okay, later on, and then you look at here. S is high. R is low. So what is Q at this point? Q will be high or low? Huh?
High.
Okay.
Oh,
Q will be high. Okay, it will be high until here. Okay. Okay, now look at this part. Can you see here? My cursor here, this is where S goes down and R is also down. When both are 1, these are still at point of enable high. So when both are low, S low, R low, what happened? Go back to the truth table. R and S is low. What is the condition for Q? No change, right? Okay, no change. So even though this is high, this low and low, so no change. So you have high here. At this part, this enable is low. So when the enable is low here, the latch is not respond to this low part. So all this part will be high. Okay, from here to here, it will become high. Until at this positive edge for the second clock of enable here, you see here, R is high, S is low. So what happened here? What is Q? Just now high, and then what happened to Q? At this point, at the positive edge of the second clock there. Irdina, what happened? It will become low. Okay, it become low here, this part here. Okay, and then look at here, this part here is low, enable low. So enable low, it will not respond to the input. Okay, and then at that point also, you see here, S and R are low. So when S and R are low, there is no change. So here will be low until here. Then you see here, this enable is high, and then set is high. So this part will be high and so on. Okay, so look at the response for Q. Okay, so keep in mind that S and R are only active when enable is high. Okay, so this part enable high, enable high, enable high. So important to look at this point. So this is when S is 1. S is 1 meaning S set, set. So Q is high. Okay, Q is high until here, but look at here because this part is still high, but here is low and low, low and low, no change. So you have high until the next enable clock here. Okay, at this point, reset is high. So reset is high, it becomes low until the next clock time here. Okay, and this part, this is when set is high, so Q will be high and so on. Faham tak? Do you know how to draw this graph? Okay, faham tak?
Okay, doctor.
Okay. Okay, now gated SR latch. Okay, look at the symbol here. This is the symbol. You have SR enable here, and then look at here. You have extra circuit here. NAND gate. Okay, so this is easy for you because you already have the input and the outputs given here. Baru tak nampak. Can you draw the output? Q. Here, this is the where the enable, remember enable must be high, okay, for the latch to respond. So this part is high, high and high. So when high is higher, so this is set. So you start with Q low, so you will get high here, okay, until here. This part is R is high, so Q will be low until here. Okay, this part is all high here for enable. So you look one by one. At this point, just now low, this point S is high. So you get high until here. Okay, now at this point, R is high. So it goes down. Okay, and then it goes high again. Okay, so see here, this is part set or SI. Until here, R is high, so it goes low. And then this part is set is high, so you get high here. And then here R is high, so it become low here. And this part is S is high, so you get this. Okay? Any question you want to ask? Here. Is it from this slide? From this slide? Okay. Which one? Here. At this point, you see here the enable is still low. Okay, so it's not going to respond when, remember the latch is not respond when enable is low. It's only respond to when enable is high. So now this is low. So you make it low lah. You start Q with low, senang. Okay. So at this point only you look when enable is high. So you make a dash line like this. Okay, you see this is high. So you get high. Okay. Remember, enable is important. You look at enable. Enable must be high. Okay, now gated D latch. The D latch is a variation of the SR latch but combine the S and R input into a single D input as shown. Okay, if you look at this circuit, it's the same as SR, but now you connect, okay, the S here to the other NAND gate here, but you have a NOT gate here. So now the design, okay, you modify a bit of the SR latch, you or gated SR latch, then you get a D latch. Okay, so the D latch we have D enable Q and Q bar. This is the symbol. Okay, simple rule for the D latch is Q follows D when the enable is active. Okay, remember here Q follow D when enable is active. Okay, now this is the truth table for the D latch, summarizes its operation. If enable is low, okay, if enable is low, there is no change in the output and it is latch. Okay, so enable must be high. So we look at here, enable high. So Q follows D. So Q is 0 when D is 0. Q is 1 when D is 1. Of course, Q bar is invert of Q. So when Q is 0, this is reset. When Q is 1, it is set. Okay, so when enable is 0, so there is no change. Okay. Okay, now you can try to draw the timing diagram or the waveform for Q. Determine the Q output for the D latch given the inputs shown. So this is the D latch. Okay, can you draw the output here? Boleh tak draw the input, the output?
Boleh Dr.
Boleh lukis. Nick, dah siap dah Nick?
Belum.
Remember Q follow D when enable is high. So this is the part when Q is high. So you can see here Q is high. Okay, and then it goes down. Okay, and then this part is enable low, so no change. Okay, and this part Q is high. So you look at here, D is high, so it becomes high, and then it goes low, and then low until here. And then because enable is low, it becomes low all the way until at this point. You see here, this part when enable is high, so low here, and then it follow going up and so on. So you get this output. Okay. So this part, nampak tak? Can you see enable is high? So when enable is high, Q follow D. So exactly the same. See? High, low. Okay, this part is enable low, so no change. Because previously is low, becomes low. At this point, enable is high. So it follows D, right? So D is high. So now D is high and then going down and then going down. Because here low again, going down, no change until this part. This is enable is high. So this is low and then you have this high, so you have high. So notice that the enable is not active during these times, so the output is latch. Okay? Okay, now this is another example for the latch. Okay, so now look at here. This is when the enable high, enable high, enable is high. And also here. So remember, Q follow D when enable is high. So here is low, so you have low. This part is high, right? so it becomes high. Okay, but enable is low, no change, so it continue to be high until the next enable here. This is low, so you're going down, and then because this is low, so then no change until the next clock enable clock here. This is high, so it goes up. Okay, even though here is low, but no change here. So because his part is high, so it high until you see enable is high. So here enable is high, but D is low. So Q follow D low, and then it just follow exactly the same format of D. So you see here the waveform here the same. Okay. Any question? Any question? Okay. Muhammad Haziq, do you have any question?
No, Doctor.
No, Doctor.
Haziq ada dua
Yes, sir.
Muhammad Haziq Yuzuddin.
No, Doctor. No, Doctor.
Okay. Muhammad Hasif. Muhammad Hafiz. Okay. Hasif Haziq. Muhammad Anas, ada soalan?
Tak ada, Doctor.
Okay, cakap banyak-banyak ada kering dekat saya, okay? Okay, now this is flip-flop. Okay, wait I want to show you a video. Kenapa dia macam ni? Wait. Okay. Can you see this video? YouTube?
Yes.
Boleh nampak? Hello?
Boleh.
Boleh, tapi
Tak dengar suara.
suara
Nak
Kami
bagi suara? Syamimi?
A control input by which we can decide.
Sorry, awak dengar tak tadi?
We have to change S or R so
sekarang
that
baru
our
dengar.
Q complement will
Oh,
disturb
saya pun tak
until
dengar
we have
tadi.
to use
Saya
it. So let's see the
termute.
difference between latch and flip-flop. In this presentation, we are going to find out the answer for this common question in digital electronics. The
Okay.
circuit here you can see is a familiar one to you. We have already discussed it. It is your SR latch. Okay, there is no control input given to it, and in this case, when there is no control input, the inputs S and R can be changed accidentally or intentionally. Therefore, this circuit is not suitable for use. So we need to introduce a control input by which we can decide that when we have to change S or R so that our output Q and Q complement will be stored until we have to use it. So let's see how we can introduce a control input to this circuit. We need two more NAND gates for this
Safwan?
purpose. The first NAND gate will go here,
Safwan ada?
and the output of this NAND gate will connect to the
Yes,
The
doctor.
second NAND gate will
Saya ada.
go here, and the output of this
Amir Sufi ada?
Okay. Now let's see what are the inputs of these two NAND gates. There is one common input.
Ada, Doctor.
Okay, bagus. Jangan tidur
And it is your control input. Okay. The other input for this first NAND gate is your S now, and I will call this S star. Okay. And the second input to this NAND gate is now R, and I will call it as R star. The working of the circuit we will see in the next presentation when we will discuss SR flip-flop. But for now, you need to know the difference between the latch and the flip-flops. So let me tell you one thing. This circuit that I made can be used as a latch as well as a flip-flop. Let's see how we can use this circuit for the latch. The only thing that decides whether the circuit is acting as a latch or as a flip-flop is this control input. If this control input is not a clock, just enable, enable. Whenever this is high, the latch will operate. Okay, so when this is enable, it means that it is what? It is level triggered. It is sensitive to the level triggering. Okay, what I mean is that, let me draw first enable. If enable is something like this, I have taken a random enable signal, then this circuit will be operational when the enable is high for this period, for this period, and for this period. And the circuit will not be operational when the enable is low for this period, and for this period. It's a very simple thing. Whenever this is the case, it will act as the latch. Okay. Now, what happened in the case of flip-flops? But before actually going to the flip-flops, let me first explain you why this circuit is operational when the enable is high. It's very simple. If I write the value for S star, then it will be S complement or En complement. So if the value of En is equal to 1, okay, which means S star is equal to S complement, and when the value of En is equal to 0, or when it is low, the value of S star is equal to what? 1. Similarly, R star will also be equal to 1 because enable is given as the input to both of this NAND gate, and in whenever there is SR latch with NAND gate, 1 1 is what? Your memory. So whatever the value or the state stored in this latch is stored until we will change En. So that's why we call it SR latch with control input. Okay, so this is the working for this, and this case when there is enable, we will call it as latch. Now let's see when the circuit will act as the flip-flop. It will act as flip-flop when we are having clock in place of enable. So clock, you already know in the last presentation, the working for the clock, the duty cycle is 50% for the clock. This is your clock. But it will be flip-flop only when there is the triggering we call as the edge triggering, which means when the clock goes from low to high or high to low. During this period only, the circuit is operational. And in that case, we call it as the flip-flop. So at the last, I want to give the conclusion for the difference between the latch and the flip-flop. The conclusion is that latch is level sensitive. Okay, whenever there is input, it will check the input. Okay, if it is enabled. Okay, but in case of flip-flop, it will check for the input and the circuit will be operational only when the clock is changing from high to low or from low to high. So this is the difference between the latch and the flip-flop. I hope you got it. In the next presentation, we will start with our SR flip-flop because now we are having everything that we require to move on with our flip-flop. So this is all for this presentation. See you in the next one.
The rocket equation. It's a beautiful thing.
Okay.
No astronaut launches for space with their fingers crossed. That's not how we deal with risk.
Okay, now look at this D flip-flop.
In this presentation, we will understand what is D flip-flop and how we can make a D flip-flop by using a SR flip-flop. You already know what is SR flip-flop, and I have made the truth table for SR flip-flop because this is the important thing from which we will derive the conclusion for our D flip-flop. Let's examine this truth table. You can see if I want to store 0, then I have to give 0 1, and if I want to store 1, then I have to give 1 0 as the input. My S will be 0, my R will be 1, then I have 0 stored in my SR flip-flop. If my S is 1, R is 0, then I have 1 stored in my SR flip-flop. Now you can see a very interesting thing, that this S and R are always complement to each other. When S is 0, R is 1, and when S is 1, R is 0. So why we have to give this S and R individually? We can just give one input to this flip-flop and complement the other. That's what we have to do to get the D flip-flop. Now you might be thinking that what about this case? You can see this is an invalid case. We are not going to use it. So if you just want your data to be stored, then you can have your D flip-flop, where D is what? Data. And it is one of the most commonly used flip-flop, because you just give your input, store the data, and remove the clock. Your data will be there. So it is a very important flip-flop, and JK flip-flop is the another most widely used flip-flop that we will see. So what we have to do to convert this SR flip-flop to D flip-flop is to extend this input. I will take this input, use a inverter, and give the output of the inverter to R. And this input I will call as D. So now you can see that when D is 0, it means when S is 0, I will have R as 1. That was this case. When D is 1, it means S is 1, and my R is 0. It means this case. So I need only a single input, that is my D, and to get the other, I will complement it. This is what we do to have our D flip-flop by using the SR flip-flop. So I can make a D flip-flop like this. In my D flip-flop, there is a single.
Don't forget to take your attendance here in
And
Putra
I'm
Belas.
having my
Okay,
clock
thank you
on
Akasha for reminding. I almost forgot.
Q and complement. And this thing is what? It is actually, let me change the color for this. If I hide this circuit and take my clock out, so you can see that this circuit is inside this box. Now this is how we will make a D flip-flop. It's time to move to the truth table for D flip-flop. Okay, a very simple truth table you will have. You will have your clock and a single input D, okay, and output Qn plus 1. Now when clock is 0, it means this circuit won't take any input, and the output will be what? The previous input. So Qn is my output in this case. When clock is high and D is low, it means what? S is 0 and R is 1. And for this particular case, I'm having Q1 plus 1 as 0. So this is 0. Now when clock is high and D is 1, I will have my S as 1 and R equal to 0. It means this case, and I'm having Q1 plus 1 as 1. And the other cases like S equal to 1, R equal to 1 is not possible in this D flip-flop, because you can see an inverter attached here, and simply we cannot have this configuration. So this is the truth table for your D flip-flop, a very simple truth table. In the next presentation, what we will have is the characteristic table and the excitation table for the D flip-flop using this truth table. So see you in the next presentation.
Okay. Have you ticked your attendance? Okay. Now we go to age-triggered G flip-flop. Okay. Flip-flop, okay, is synchronous bistable device. Okay, flip-flop is a synchronous bistable device. A flip-flop differs from a latch in a manner it changes states. Okay, a flip-flop is a clock device in which only the clock age determines when a new bit is entered. Okay, so I think in the earlier part also mentioned what is the difference. I mean, earlier notes also mentioned what is flip-flop and what is latch. Okay, so this is the H trigger D flip-flop. So you look at here, mana saya punya cursor? Look at the symbol here. You have a symbol here. Previously you have enable, right? Only enable. So now you have a clock here. Okay, so look at the difference. Okay, this is, see, this is the symbol for D latch, gated D latch. You see, you have enable only like this. The symbol is just like this, yeah. Okay. Okay, this also D latch, gated D latch. You have enable. Carefully the difference between the latch and the flip-flop. Now you look at the flip-flop. You have a clock, and you see this arrow. You must have this. This show the clock. Okay, when you draw it, make sure you have this clock. Okay, now this clock you don't have bubble. This clock you have bubble. So meaning this is negative age triggered. When you don't have the bubble here, this is positive age triggered. So now look at this is the clock. For example, you have clock here. The active age can be positive or negative. Okay, so can you see the color brown and blue in the slide? Okay, so you see the brown here, okay, shows the positive age. It shows from low goes to high. So this is the positive age. And for the blue, you see the blue color, it's from high goes to low. This is the negative age. So this flip-flop, it refers to the age here, the age of the clock. Okay, determines when it changed the state. Yeah. So dynamic input indicator here. Okay, dynamic input indicator. Okay, this is positive age trigger when you don't have bubble. When you have bubble here, this is negative age triggered. Okay, age triggered D flip-flop. The truth table for a positive age triggered D flip-flop shows an up arrow. So you see here, this is up arrow here. This is for positive. To remind you that it is sensitive to its D input only on the rising edge of the clock, otherwise it is latch. The truth table for a negative age triggered D flip-flop is identical except for the direction of arrow. See, the direction of arrow here is pointing down. So this is for negative age triggered. Here pointing up, this is positive age triggered. You see the D here. Okay, when this is high, okay, clock is high, it changes state, yeah. So Q follows T. This is set. Okay, when D is 0, Q also 0. This is reset. Okay, you see the state is the same, except it changed state at the negative age. This one changed state at the positive age. Okay, now look at this example here. Age triggered D flip-flop. Can you draw the Q response for the given clock and the D, the input for D? Can you draw? Aiman Iqbal. Aiman Iqbal. Boleh tak lukis?
Boleh.
Boleh lukis. So hari ni awak duduk kat bilik je lah. Besok dah PKP boleh keluar tak besok?
Tak tahu lah doktor.
Papa, kucing bergaduh pak kat luar. Kucing bergaduh. Hari ni last lah. Awak duduk boleh keluar. Besok ada lab lagi ke? Ada kelas mana lab? Tak ada. Untuk lecture lab, ada lab tak ada kan? Kalau ada lab pun dah tak buat dah. So nanti lepas balik raya cuti ni balik sini balik lah.
Lepas tu kuarantin.
Kuarantin 10 hari. Oh balik sini berapa hari bulan? Balik ke college? Balik ke college. Maknanya awak balik dalam berapa hari bulan?
16 hari bulan. 17 hari bulan.
Oh balik 16 hari bulan lah?
Ya.
Hari. Kuarantin berapa hari? 10. So start daripada hari balik 16 lah?
Ya betul.
Oh so hari Selasa 25 tu boleh ada lab ke tak boleh lagi? Ya. Yeah. Okay. Sebab saya choose face to face tau. Lepas awak balik. So saya still prefer to have lab. Bukan online lab Saya prefer to sebab saya rasa it's better. Betul tak? Don't you think so?
Alhamdulillah.
Takkanlah awak jadi engineer simulation kan? Kan? Mesti orang tanya engineer simulator. Simulator untuk multi-sim mana Betul Asif? Dah siap Nurin? All okay kau tidur Nurin?
Okay, doktor.
Wan Nur Adlin? All okay ke? Dah siap ke belum?
Okay, doktor.
Dah siap belum?
Dah, doktor.
Macam mana bentuk dia? From low. Senang sikit. You start from low here. Okay. Q from low and then this is positive H. Okay, dah ada pun dah. You already have this line. So you refer to this line. But in the test, you have to draw the line. I will not draw for you. So at this age, D is high. So you have what? High. And then here is low. And then here is high and so on. Look at the output. Okay. So you have here, this is high until the next clock here is low. So you low until this clock here. So this is high, you have high. Until clock here. Okay, so on. Okay, faham? Yes. Tapi enable, it's not age. It's when it is high. Remember? But for age trigger flip-flop, it refer to the age. It will change state at the age. So this is positive age, so it's change state here. Okay? Change state here. For enable, it refer when it is high. So meaning if all this high, or for example, this enable you mentioned just now, so it's refer to the high state. For example, here, here, here. Okay, when it's low, no change, right? Okay. So remember, it can change state for enable, it can change state anywhere. For example, example just now, you can have change state at the middle of the enable. Remember? Mana tadi? This enable, not this one. This one. Okay, so this enable, right? High. So you see, it does not change at the state. It can change anywhere as long as it is high. You see, you have this high. Nampak tak kat sini? Okay. This is for gated D. But for the flip-flop or age-triggered flip-flop here, it changed state at the age. Either positive age or negative age. Okay. Okay, now this is the last one. Is it over? This is the last one before we dismiss. I dismiss you. So this is toggle or T flip-flop. Output toggles when input is asserted. So if T is 1, Q goes to Q bar when clock is high. And if T is equal to 0, then Q goes to Q when clock is high. Okay, so you can see here, and this is the symbol for T flip-flop. There's a clock. Remember, you always have this arrow here, symbol here. This is to show this is a clock, input and then Q. So if input is 0, Q is 0, and then next state, this is next state. When T plus T, delta T meaning the next state. Okay, when Q is 0, Q is 1, input is 1, sorry. Input is 0, Q is 1, so the next state is 1. Input is 1, Q is 0, next state is 1. When input is 1, Q is 1, okay, next state is 0. Okay, so you will have a better picture when you do some exercise later on, yeah? Okay. Or problems, okay? Saya punya ni rosak. Okay, and then next one is JK flip-flop. Okay, we stop here. Okay, any question before we start? Have you done the question I asked you to solve yesterday in the lab? The multiplexer there? Have you done that? Hello? Syamini?
Not yet, Doctor.
Not yet. Bila nak buat? When do you want to... kenapa dia tulis apa saya cakap pula? When do you want to do the exercise?
Got the turn off caption sebelah
Kat
kanan
mana?
raise hand.
Kat mana? Ni?
Tu.
Ya, tu Dr. Caption.
Okay, dia dah turn off. Sama macam hari tu. Tahu apa jadi? Saya order food panda. Makanan untuk mak saya. Saya tak tahu apa benda. First time saya guna food panda. Lepas tu bila saya type bahasa Melayu, nanti bila saya send, dia jadi bahasa Inggeris. Bila saya type bahasa Melayu, dia jadi bahasa Inggeris. Lama saya lawak. Saya tanya kat anak. Saya cakap dengan orang yang nak hantar tu, saya kata kenapa? Bila saya tulis orang putih bahasa Melayu, dia dapat bahasa Inggeris. Aduh, lepas tu anak saya datang check. Dia kata, mama ni tak tekan kat sini ni, dia kata. Tekan kat sini barulah bila tulis Melayu, dia akan keluar bahasa Melayu juga. Bukan dia translate. Aduh, hai. Tergelak saya dalam kereta, masa nak tergelak kan. Tak kerti guna first time. Okay, so bila awak nak buat awak punya exercise?
Be today.
When are you going back?
Some of us are going back on Friday, I think.
Friday. Okay, so good. I give you exercise, you check your Putra Blast, yeah? Okay?
Okay, Doctor.
Okay, see you after the holiday. Bye.
Bye, thank you, Doctor.
Bye, Doctor.
Bye, Raya.
Raya,
Okay.
Kembali.
Thank you, Doctor.
Selamat Raya.
Raya.
Thank you, Doctor. Thank you, Doctor.
Okay.
Terima kasih, Doctor.
Terima kasih Doktor. Assalamualaikum.
Bye-bye, Dr.